everyone, thank you so much for clicking onto the video. Here are today's learning objectives. So the first is to look at the techniques and procedures used when preparing a standard solution of required concentration and carrying out acid-base titrations, and then look at the structured and non-structured titration calculations based on experimental results of familiar and non-familiar acids and bases. We're then going to look at a required practical, which is making a standard solution and carrying out an acid-base titration. So now we're going to have a look at titration calculations. And titrations can be used to find the concentration of a solution. So, for example, an alkali, by reacting the acid with an alkali using a suitable indicator. And so the two things that we need to know is the concentration of the acid being used and also the equation for the reaction between the acid and the alkali. So a bit later on, we're going to be looking at the required practical, which is a titration. So that's when I'll go through what a titration actually is. But we're just going to look at how to calculate the concentration of a solution, so the unknown concentration, from the concentration of the other solution. So in this case, it's going to be an acid, and using the equation. So our example is, what is the concentration of sodium hydroxide if 25 centimeters cubed of the solution is placed in the conical flask and 18 centimeters cubed of 0.35 moles per decimeters cubed of HCl was needed to neutralize the sodium hydroxide? So the first thing we can do is write out the equation. So we have some sodium hydroxide, and this is in solution, so we call it aqueous. And then we have some hydrochloric acid, and this is also dissolved in water. And this will form a salt and a water because this is a neutralization reaction. So we have the salt, which is sodium chloride, and then we also form water. And this equation is already balanced, so we don't need to add any numbers. So the next thing we can do is work out the moles we have of hydrochloric acid. And so we have that the moles of HCl is equal to the concentration multiplied by the volume. So we have the concentration is 0.35 and then multiplied by the volume, but the volume has to be in decimeters cubed. And so we have to convert this 18 centimeters cubed, and we do that by dividing it by 1,000 or multiplying by 10 to the power of minus 3. And so we get 6.30 times 10 to the minus 3 moles. And now what we can do is use this equation to find the ratio between sodium hydroxide and hydrochloric acid. So from equation, we have that 1 mole of hydrochloric acid will react with 1 mole of sodium hydroxide. And so if we have 6.30 times 10 to the minus 3 moles of hydrochloric acid, then this must react with 6.30 times 10 to the minus 3 moles of sodium hydroxide because they're in a 1-to-1 ratio. And so now we can work out the concentration of our sodium hydroxide because now we have the moles of it and also the volume. So we have that the concentration of this sodium hydroxide is equal to, so we need to rearrange the formula we have. So we have moles is equal to concentration multiplied by volume. And so the concentration must be equal to moles over the volume. And so we have that the concentration of sodium hydroxide is equal to 6.30 times 10 to the minus 3 divided by the volume, which is our 25 centimeters cubed. And so we have to convert this to decimeters cubed again. So we have 25.00 times 10 to the minus 3 because we have to divide it by 1,000. And so this gives us 0.25 moles per decimeters cubed.